Hi, Miss Barron here. In this video, I'm going to be talking about dissociation. So what is dissociation? It is when you have a solute, so for example, sodium chloride, which is NaCl, and you dissolve it in a solvent, such as water. NaCl is the solute. And it dissolves and dissociates and breaks up into its individual ions. Okay, so you can see here in this picture, the sodium chloride, the Na, which is the smaller one that has the positive when it dissociates into an ion, and the chlorine has a negative when it dissociates into an ion. You can see here that when it completely dissolves, it is broken up into these individual ions. So that's what dissociation is, when you have a solute that is soluble, that can dissolve in a solvent such as water. It will break up into its individual ions. So dissociation is the separation of ions. That is anything that has a positive or negative charge. It's something that has lost or gained an electron when an ionic compound dissolves, and that usually happens in water. So the example that I used was sodium chloride, which is NaCl, dissolving in water, and you get the Na plus and the Cl minus ions. So now you're going to start seeing some of these subscripts. So solid, liquid, gas, that should be pretty familiar, those different phases of matter. However, what might not be so familiar is AQ. So that stands for aqueous. That just means something has dissolved in a solution. So like if you had salt water, that would be aqueous because you had this solid, but it dissolved, it broke up into its individual ions in the solution. So we call that aqueous. So let's say instead, now we have this, which is calcium chloride, CaCl2. That would dissociate in water. So you would get the calcium. This would have a charge of +2. I'm getting that from, if I look on my periodic table, calcium is in group 2. It would form a charge of +2 as an ion. This would then be aqueous. Plus, then you have the chlorine ion that has a charge of -1, also aqueous. But notice though that there's a 2 here, so we have to put a 2 in front so we can make that equation balanced. Now remember these numbers in the front, so I have a 2 here, there's 1s here, they're just placeholders, you don't have to write the 1s, but that's what is there. So if I have 1 mole of the calcium chloride, CaCl2, that dissociated, how many moles of calcium ions and how many moles of chloride ions would you get? Well, if we look here, we can see we have 1 mole of the calcium ions. Those numbers in the front, those are coefficients, but they also represent the number of moles. And then we have 2 moles of the chloride ions. So those numbers in front, those are what we put there to 1, balance the equation. They're called the coefficients. And 2, they also represent the number of moles. It is the mole to mole ratio. So I have a few more examples here. So let's say write the equation for the dissociation of 1 mole. So I have 1 mole of Al2SO4 3. Okay. So this would be some type of a solid, and I would put that into water. Okay. So when it dissociates, it's going to break up into its individual components. Now the SO4, that is a polyatomic ion. So that is something you would find on the back of your periodic table. So you treat it as if it were an individual element, okay? That's why over here it's written in parentheses. You're treating it as if it were an individual element like the aluminum here. So on my periodic table, if I were to look up the charges, aluminum is in group 13. This would have a charge of +3. And then the SO4, I would have to look on the back of my periodic table to find the charge of that. And that would have a charge of -2. Since these are dissociated in water, we would write AQ for aqueous. Now the last thing we have to do is make sure this is balanced. So notice on this side of the equation, I have aluminum and it has that 2. So I'm going to write that 2 here. So that's where the 2 is coming from. And also notice I have a 3 here for the SO4. So I have to put a 3 in the front of this. So that's where I'm getting those numbers from. And this is to make sure that it is balanced on either side. So how many moles of each ion do you have? Well, we have 2 moles of aluminum ion. So when I write it like this, I'm saying this is an aluminum ion because it has that charge on it, that +3. And then I have 3 moles of the SO4 ions. So in total, actually we're going to skip this. That actually is not important for this particular step. Okay. Do another example. Again, I'm going to cross that off. So again, just like we did up here, very similar, you would dissociate. So you would start with 1 mole. In this case, they gave us AlOH3. And this would be something solid that we would place into water that would dissociate and dissolve. So you have the aluminum and you have the OH. So again, the OH, that is a hydroxide ion. That's something that you would find on the back of your periodic table. So again, the aluminum, we said earlier, that has a charge of +3. Again, these are ions. They have charges on them. And the OH, that you would find on the back of your periodic table, that has a charge of -1. And these would also be aqueous. The last thing I would have to do is balance this. Oops, I'm just going to write a 1 there. We don't have to write the mole. The 1 represents 1 mole. So on this side, there's just 1 aluminum, and there's 1 aluminum here. So if you want to write a 1 in front, you can. But again, you don't have to write the 1. It's more so of a placeholder, but if you want to write it, you can. Technically, this would be acceptable as well. But if you'd like to write the 1, you can go ahead and do that. And then on this side, we have 3 hydroxide ions. So I'd have to put a 3 in front of that OH so that it is balanced. So I have 1 mole of the aluminum ions, and then I have 3 moles of the OH, which is the hydroxide ions. Okay. So all you're doing is you're taking that compound that is soluble, you would dissolve it in water, and when you do that, you break it up into its individual ions. So ions are something that have a charge on them, so the plus or the minus. And you have to make sure that the equation is balanced on either side. So now we're going to use that equation to do some conversions. So this is very similar to stoichiometry. We're actually doing a mole-to-mole conversion, which is pretty similar to what you see with stoichiometry. So let's say I have 9.5 moles of CaNO3, so that'd be calcium nitrate, and it dissociates. How many moles of nitrate ions would be in the solution? Well, the first thing you have to do is you have to write the dissociation of just 1 mole. So I'm just going to start with 1 mole, that 1 in front. You don't have to put it there, but you can if you want. We're going to disassociate this into its individual components. So you'd have the calcium and NO3, that's another polyatomic ion. You would find that on the back of your periodic table. The calcium, that's in group 2, that would have a charge of +2. And the NO3, the charge of that you would find on the back of your periodic table, which is -1. Now we have to balance it. So there's 1 calcium here, 1 calcium here. Notice there are 2 nitrates on that side, so I do have to put the 2 in front of that. So this is my disassociation equation. I could put a 1 here too, I don't have to. So this equation is balanced. Those numbers in the front represent the number of moles. We can actually use this to do a mole-to-mole conversion, and we can set up our picket fence. So it asked us in the question, if you have 9.5 moles of CaNO3(2), and you need to convert that into moles of NO3 ions. Well, the 2 things that you're going to plug in here, you're going to pull from the equation. So I know in the bottom here, the units have to be the same. So if I have moles of CaNO3(2) here, I also have to have moles of NaCO3(2) here. Now, where am I going to get this number from? Well, that's going to come from the balanced chemical equation, okay? So that's where that number is coming from. If I put that number in the bottom and that number came from the balanced chemical equation, the number that whatever I put above it should also come from the equation as well. Well, I'm trying to find how many moles of NO3 ions. Well, if I look at the equation here, moles of NO3 ions, well, the equation is telling me I have 2 moles of NO3 ions, or nitrate ions. Now, just like any other picket fence, you multiply everything in the top, and then you divide by the bottom. So the bottom is just 1. So all we're going to do is, let me get my calculator. We're just going to do 9.5 times 2, and then you would divide by the bottom, which is 1, so you would still get the same answer. So we would have 19 moles of NO3 minus 1 ions, because moles of CaNO3 would cancel in the top and the bottom. Okay. And I would do something very similar here with this equation as well. Now, for your practice, for the dissociation worksheet, you have these 3 equations, which you'll write the dissociation for, and then you'll use those equations to help you answer these questions here, okay? You can actually skip this question, how many ions in total were produced. You could skip that one. But these 3 here will be the picket fence, and you're just going to use the balanced equations that you wrote up here to answer those 3 questions.